All right, so in this one, we've got a rod leaning up against a wall, and the wall has some friction, but the floor, for whatever reason, does not. Okay, so maybe this is a rod leaning up against a wall in an ice skating rink? Anyway, we've got a force P there, and the force P is going to hold the thing against the wall. Okay. Let's go ahead and put our other forces in there. We'll start with the low-hanging fruit, which is gravity, of course. Oops. Got the wrong pin right out of the basket there. Okay, so here's our weight. Okay, and if we start then at point B, we're going to have a normal force here. So we'll call that NB. And of course, we'll have a normal force over here in A. Then the rod would like to slide down the wall, and so the friction, that's our impending motion, so the friction is going to impose that, and we'll end up with our friction up here like this. Okay. Now it's important to remember that that's actually going to be mu times NA. Okay, so that friction and that normal force are linked together. They're proportional to one another. All right, so let's dig into it here. We're going to have our vertical forces. We've got NB up. Oops. NB. The weight down, and the friction up. Okay, and so the weight and whatever's happening at B in B there are helping each other. They're sharing the load literally for W. Okay. Looking at the horizontal component of all of our forces, we're going to have P minus F. Okay. Oh, no, not okay. Not cool. That didn't seem quite right to me. It's actually NA up there is what that is. NA. Okay. And so we can learn right off the bat that P is equal to NA. Okay. So that's helpful. Alrighty. Okay, and now we're going to need another equation. Okay, let me show you why. Down here we can write this plus mu NA. Okay, so I really have, at this point, I've got 3 unknowns and I've got 2 equations, so we need one more equation. And so we're going to tap into some moment for that. Okay, so let me do that over here. All right, we just got to figure out where we want to do it at. Okay, so if we do it down there at B, let's think this through. If we do it down here at B, okay, then we get a moment from here, and from here. Now we know the weight, and so that would mean the only unknown really is NA. Okay, let's look at our other options. That's a pretty good one, to be real honest. So if we do here, then that's just going to get messy. Okay, I don't like the looks of that one. It eliminates the one thing we actually know. So that's not a good option. Let's come in here with this. Okay, so that eliminates NA. Okay, we don't know that. We've got W, then we've got NB, and we've got P. Okay, so that would mean we've got 2 unknowns that way. Okay, so really B is our best option because it looks like that's just going to set us up with only a single unknown. So let's do that. So we're going to put our pivot down here. Okay, so we're going to pivot at B. Okay, so W is out there. Here's our line of action, a distance 2. So we've got 2W, and it's negative. And then let's move to NA. Okay, so NA's got a line of action over here. So that's 3, and it's negative. So minus 3 in A. And then our friction's line of action is along here. So that's 4. It's also negative. So we've got minus 4 times the friction, which is equal to 0. Okay. Boom. Oh, sorry about that. NA is... Oh, I got both of those backwards. Okay, well, that's an easy fix. Positive, positive. There we go. You guys would have caught that right away if we'd been doing this in class. Okay, now F is... there's an NA buried there inside of F. So we've really got minus 2W plus 3NA plus 4 mu NA is equal to 0. Okay, so now if we do some algebra, we regroup some things, we're going to have NA. Okay, and 2W, 2 times the weight. Let me redo that one. That W looked like an omega. There we go. And then on the bottom here, we're going to have a 3 plus 4 mu. Okay, and there we're done. We're done. Okay, so let me show you. Because we're looking for P, right? This guy right here is going to get us NA. NA is going to get us to P. Okay, and that's all there is to that guy right there. Okay, now, what if there had been some friction down here? Okay, what if there'd been some friction down there? Well, what would have happened then is in our horizontal forces equation, we would have had an F inside there. Okay, and it would have depended on mu, but it would have also depended on NB. So we would have ended up having mu NB plus P minus NA is equal to 0. Okay, and so not too bad. That'd have been all right. But that's what we would have had to have dealt with if it had turned out that we had, some friction down there on the floor. Okay. But fortunately, in this case, we didn't. So I don't need to worry about that. Okay. All right. There we go. So that's pretty straightforward, guys. We'll close this one out. Get ready for the next one.